Welcome to our Expo poster presentation. Our project is about the transportation infrastructure perception data fusion and detection using AI technology. The project objective was to utilize a variety of sensors. Those include the LiDAR, radar, 360 camera, stereo depth camera, and thermal camera for the detecting and tracking of mixed traffic objects. The data was then cleansed through machine learning algorithms and collected onto a database for traffic safety analysis. The data capture setup is shown on the right, and the all-in-one mount model that was made for the convenience of future recording sessions is shown on the lower left. This would allow consistent spacing for the devices.
This is the project operation process. It offers a high-level breakdown of the entire data collection process. As you can see, each device has its own raw data output, thus requiring its own post-processing techniques. After these techniques are performed, they are collected on the database in a CSV format. This is where the final steps of data fusion and traffic safety decisions are made. The stereo depth camera is a camera that allows the capture of depth information. This gives us insight into the third dimension, which allows the approximation of object size and of calculation of velocity. Here, the bright colors in the right two images correspond to greater depth.
LiDAR data is in the form of point clouds that are based on the reflection of an infrared laser from a point on an object in three-dimensional space. QGIS mapping is used to convert the object's XYZ coordinates from the LiDAR into a form that allows decision makers to quickly visualize the most common vehicle and pedestrian movements on a map to help enact appropriate policies. Since the LiDAR and 360 camera both provide a 360-degree field of view, the 360-degree camera can be used to verify LiDAR detections.
Thermal cameras offer detection advantages in several low visibility scenarios, whether that's weather, glare, or darkness.
Two radars were used to detect targets. Utilizing signals sent towards the target from various angles, the radar can then detect any objects. The features from these targets, for example, its amplitude, distance, and velocity, can then be used to classify them using machine learning.
The transportation infrastructure perception system developed by this project has several real-world applications, many involving traffic safety. They'll be able to detect stuff such as violations, build simulations, or create 3D reconstructions of traffic. This will allow greater confidence in planning of infrastructure and roadways, and the automation of the device and data process have been a challenge, but can be improved upon in the future iterations and data fusion to serve these applications.